We are standing at the bottom of a 30-degree sloping hill. From here, we launch a projectile with an initial velocity of 40 meters per second in a direction making an angle of 30 degrees with the hill. In other words, the initial velocity of 40 meters per second makes an angle of 60 degrees with the horizontal. Now this projectile will fly under the action of gravity and land somewhere on the hill. The question is, how far along the hill does it land? The first step in solving any physics problem is making a drawing. We have done that. The second step is choosing a coordinate system. Now, two coordinate systems suggest themselves. One is the usual x-axis pointing to the right and y-axis pointing straight up vertically. The other one is the x-axis along the incline and y-axis perpendicular to the incline. It's a good rule to always choose one of the axes to point in the direction of the acceleration if you know the direction of the acceleration. Now, while the projectile is flying, at any instant, the force of gravity is acting straight down, and hence the acceleration is straight down. So it is better to choose our y-axis vertically. So we will not choose this coordinate system. Let's get rid of that. And we will take x-axis along the horizontal and y-axis directly upwards. Once you choose your coordinate system, you write down all the quantities, which are the initial velocity, acceleration, etc. in terms of their x and y components. The initial velocity is x component is 40 cos 60. Cos 60 is half, so that is 20 meters per second. And in the y direction, the y component of the initial velocity is 40 sine 60 degrees. Sine 60 is root 3 by 2, so this becomes 20 root 3 meters per second. This acceleration due to gravity has no x component. Ax is 0, whereas Ay is minus 10 meters per second squared. This is the reason we choose x and y axis like this, because the acceleration splits into very simple components. Now we can write down Vx, Vy, Sx, Sy. But what are Sx and Sy? Sx is nothing but the change in the x coordinate of the particle. Sy is nothing but the change in the y coordinate of the particle. This is the displacement in the y direction. This is the displacement in the x direction. So when the particle finally lands on the hill, if I drop a perpendicular there, the change in the x coordinate is this horizontal distance, AB, that is Sx, and BC is Sy. As it is flying, delta x, the change in the x coordinate, keeps increasing. The change in the y coordinate first increases, then it decreases. But when it lands on the hill, Sy and Sx have a simple relationship between the two. If you look at this 30-degree right angle triangle, Sy divided by Sx is tan 30. Let's write this relationship down out here. I'm going to write it here for lack of space. Sy, if you look at this, uy is 20 root 3. So 20 root 3 t ut plus half a. Half a is minus 5. So minus 5 t squared. That is Sy. Divided by Sx. But what is Sx? Uxt, that is 20t plus half ax t squared, but ax is 0. So this is equal to tan 30 1 by root 3. If I now cross multiply, it's going to be root 3 times 20 root 3t. Root 3 times root 3 is 3. 3 times 20 is 60t minus 5 root 3t squared is equal to 20t goes to that side, 20t. If I bring 20t this side, this becomes 40t minus 5 root 3t squared is equal to 0. And if I take t outside, I get 40 minus 5 root 3t is 0. And the two answers I get are t equal to 0 and t is equal to 8 by root 3 seconds. At t is equal to 0 also it is on the incline. So it satisfies this relationship. 8 by root 3 seconds later it is again on the incline. So the time of flight is 8 by root 3 seconds. Now all I have to do to find the distance along the incline where it lands is to find Sx and Sy and use Pythagoras theorem. Now that I know the time 8 by root 3, I just need to substitute 20 root 3 multiplied by 8 by root 3, that is 160, minus 5 times t squared, that is 64 times 5 divided by 3, that gives 320 divided by 3. This is 480 minus 320, which is 160 by 3. That is Sy. Similarly, Sx. Sx is 20 times t. So Sx is simply 20 multiplied by 8 by root 3, 160 by root 3. Let's clear some space. So now we have a final answer. The hypotenuse S, the distance along the incline, is given by S is equal to square root of 160 by root 3 the whole squared plus 160 by 3 the whole squared. I want square root of that. I will let you finish that. What if the hill were sloping down instead of up? Let's do that next. We have a 30-degree incline from the top of which a projectile is launched with an initial velocity of 40 meters per second, making an angle of 30 degrees with the horizontal. So if I draw a horizontal line out here, then this angle is 30 degrees. We are interested in finding out how far down the incline it lands. So as always, we set up a coordinate system first. We will take the x-axis horizontally and the y-axis vertically upwards. Always choose one of the axes in such a way that the acceleration, if you know the direction of the acceleration, lies along the axis. Now we know that as it flies in its trajectory, the acceleration is downwards, so we'll take it along the y-axis. X, y. In the x direction, the initial velocity has a component 40 cos 30. Cos 30 is root 3 by 2, so that is 20 root 3 meters per second. In the y direction, the initial velocity has a component uy is 40 sine 30. Sine 30 is half, so that is 20 meters per second. The acceleration in the x direction is 0. The only force is gravity, therefore the acceleration is only in the negative y direction, and hence the acceleration in the y direction is minus 10 meters per second square. When it lands on the incline, what is Sx and Sy? Let me drop a perpendicular from here. I drop a perpendicular from here and draw a horizontal line like so. And now we are ready to say what is Sx and Sy. Sx by definition is the change in the x coordinate, which is from A to B, that is Sx. That's the change in the x coordinate. And Sy is change in the y coordinate from C to B. The change in the y coordinate is Ca, so that is Sy. We have to be careful here. Notice that since we have taken up as positive, Sy is a negative number. That is, the change in the y coordinate is negative. Right. So what is the formula for Sy? It's Uy t plus half Ay t squared. The formula for Sx is Ux t plus half Ax t squared, but Ax is 0. Now if you look at this right angle triangle, this angle is 30 degrees. You might be tempted to say Sy by Sx is tan 30. But you have to be careful. Tan 30 is the length of the opposite side divided by the length of the adjacent side. Sy, on the other hand, is a negative number, so the length of the opposite side is minus Sy. Once again, the change in the y coordinate is negative, so the length of the opposite side, Sy itself is a negative number, so minus Sy is a positive number. That's the length of the opposite side divided by Sx, which is positive anyway, is tan 30, which is 1 by root 3. So let's substitute. This is Sy. Minus of Sy is 5t squared minus 20t divided by Sx, which is 20 root 3t, is going to be equal to 1 by root 3. Cross multiply and solve for t. We get t is equal to 8 seconds. Now we can substitute back into Sy and Sx. So minus Sy, which is the opposite side, if I substitute 8 seconds, becomes minus Sy is equal to 5 times 64, that is 320, minus 20 times 8, 160, that is 160. Sx, on the other hand, is 20 root 3 times 8, that becomes 160 root 3. So this length is 160 root 3, this length is 160, so the distance along the incline, I can use Pythagoras theorem, and so my final answer is 160 root 3 the whole squared plus 160 squared, square root of the whole thing. You can evaluate this number for yourself.